Assalamualaikum warahmatullahi wabarakatuh. For this time, we'll focus on lab 27.2.15 about the investigating a malware exploit. We have four objectives here in this lab. First objective is more on using the Kibana to learn about the malware exploit and then investigate the exploit with skill and use Wireshark to investigate an attack in network level. And lastly, we'll examine the exploit artifact. So this lab is based on the access from the website malwaretrafficanalysis.net, which is actually an excellent resource for learning how to analyze the network and the host attack. So we need to thank to the author that giving us the permission to use this material. So for the background scenario, this event actually happened in January 2017 and discovered by the SNOT and IDS. Network interface and network intrusion detection system, which already embedded in security onion and squid. So we require security onion virtual machine and the internet access. So you need to ensure that your security onion virtual machine are connected to internet so that we can do it, we can analyze it in real environment or in directly to the specific resource. So we'll use Kibana first, part 1, already log in, and then we need to go to Kibana, same credential with CyberOps, and this CyberOps or password. First of all, we need to zoom in, narrow down the timeline for the log of data into January 2017 until we get this view. So how to do that? We need to go to this time range, go to absolute. For me, I just click 2017 January 1st to 2017 January 31st. Okay, then click. And you see we get the same output here, 1910, right? 1910 numbers of log, total number of log. So you see here the point, the count numbers. So how to zoom in? We need to click in this part and drag it until we have 5 seconds. This one more on 12 hour until 5 seconds. Make it slowly. This one. Now 10 minutes. 5 minutes. You need to be patient when using the virtual environment, especially when we're having limited resources, because as a laptop user, normally we just having dual core, octa core processor and then limited numbers of RAM. Okay, now 5 seconds, right? Okay, this is after 5 seconds. Then in step 2, we need to specify the alert only for NIDS alert. We have other alert here like Zig Notice, Elast alert, and HIDS, host-based intrusion detection system. Normally in HIDS, they will use the file integrity measurement tools. Okay, we'll see later. And IDS here, normally they will embed the snot engine, which having updated rules, you can automatically update the rules. Similarly with the Cisco ESA appliance, they have embed also the snot engine and also auto updates of the snot rules. So now for NIDS, we have same value, alert number, alert total number of alert for NIDS from January 1 to January 31st, actually 147 here. It's already specified the numbers. Same output here. So next, we need to move until timestamp per second. This one per 5 seconds. So we need one more time to do this. One time only. If more than that, you're having, because I choose not fully, but it will show me 135. Okay, they have more here. So can go to this first point, timestamp per second 20 to 23 attack count. So you see what happened here. January 27 2001 7, then 22 hours 54 minutes and also 43 seconds. Is it same? Yes, we got same output here. What we need to do now, view detail for the event that occurred at that time. Scroll all the way to the bottom of the dashboard until you see an IDS alert. This is the alert section. The alert are arranged by time. Expand the first event in the list by clicking the point, narrow that. So we need to go to this, but then we can see the details. So now you need to answer. You need to answer the question from this. So I already have my own answer here. For example, look at the expanded alert detail and answer the following question. What is the time of the first detected NISDS alert in Kibana? So you see here, the first one, right? This is the date time, January 27, 2001, 7 at 22, 54 and 43 seconds. So 10 p.m., right? So what is the source IP address in the alert? So you can see here, source IP 172.16.4.193. And then what is the destination IP address? So here, the destination IP address, here, right? 194.87.234.129. And then, what is the destination port in the alert? What service is this? When you see here, destination port is port 80. We know already, port 80 is a HTTP service for the web server service. Then what is the classification of the alert? How to get the classification of alert? We see here, classification is under Trojan activity. From the alert, this is the Trojan activity. And what is the destination geo country name? You can find here destination geo country name is Russia. Destination of the country is the Russia. So next, F. In a web browser or computer that can connect to the internet, go to the link that provided in the signature info field. Alert. This will take you to emerging threats, not alert rules for the exploit. So they are the series of rules down. This is because signature can change over time, or new or more accurate rules are developed. The newest rules at the top of the page examine the detail of the rules. So we need to go to uh, the link provided. This again, this one signature info. Click. So this is the rules. It's not rules. Actually, before this, they have another rules already created or developed based on the attacks. But when they detect additional or newest attack, they will update the rules so that when the packet contain that kind of attack, it's not engine will alert based on the rules or pattern they detected. Based on the network traffic they analyze, then they will map with which rules. This is the latest rules here for the snot engine. It's not rules. So what is the malware family for this man? From these rules we can see, you can find about the malware family. Malware family, exploit kit RIG. Alright, call it as exploit kit RIG. So what is the severity of the exploit? Here, signature severity are major. But you see another part here, performance impact is low. Yes, for the performance is low, but the severity of signature are classified as major. And then what is exploit kit? Search for the internet to answer the question. You can find about the exploit kit itself on the net, so that's why you need the internet. What is exploit kit? So I found that the exploit kit is looks like a hacking toolkit, or can consider as cyber criminal toolkits that can be used to exploit any vulnerability of the system, which for this case they use multiple websites and redirect to infect a computer with a malware. Ultimately, the exploit kit will exploiting the vulnerability for the system or the application, and then try to infect the computer or the victim. We'll see later what type of vulnerability this attack will exploit. Normally they will use CVE list, common vulnerability exposure list, so that they can attack the specific apps for this kind of attack. Okay, you can read here, exploit is frequently used drive by attack to begin attack campaign. Drive by attack, a user will visit a website that should be considered safe. However, threat actors find a way to compromise the legitimate website by finding vulnerability on the web server and host them. Normally, they will find the web server that are not regularly maintained, maybe not regularly update, so that the web admin not aware about it. They will use it. The vulnerability allows threat actors to insert their own malicious code into the HTML of the website, so that when user click the website, they will activate any code that embed inside the web HTML. The code is frequently inserted into iframe. Iframe permit content from different websites to be displayed in the same page website, same web page. Threat actor will frequently create an invisible iframe. This is the features for HTML, but is misused, manipulated by the threat actor. Then the HTML from the website that is loaded into the browser often contain a JavaScript that will be sent the browser to the malicious website or download malware until the computer affected. Okay, this is the way they doing it. So now, step 3, view the transcript CAPME. Click the alert ID value. You can pivot to CAPME to inspect the transcript of the event. So we go to our Kibana and look at the ID. Here is the ID, right? This is CAPME. In the CAPME windows, you can see the transcript from the session here. It shows the transcript, the transaction between the source computer in blue and the destination that are accessed by the source. A lot of valuable information here, including a link to the PCAP file and that is related to this alert. It's available in the transcript. So you can see here PCAP file related to this alert, which captured by the analyzer. This is the request file was gzip compressed. You can detect what type of file actually requested, and then the timestamp. This is the timestamp that stated in our report, generated report. So the GET request for the file itself contained here also in the transcript, and then the compromise the referring website. This is the website that compromised by the threat actor and make it their inject the code there. So resuming the first block, this is request from the source to destination web server. Note that two URL are listed in this block. You can see here. The first as a resource or referral. So this is the website that the source computer first accessed. However, the server referred browser, the HTTP GET request to the source host. Something in HTML send the source to this site. It looks like could be a drive-by attack. When we see here, we can guess that this is the drive-by attack. So what website did the user intend to connect to? So when they're searching for something in the web search, search engine, they will find maybe in the first rank, second rank about the web that they want to visit. Then they just click lah. So in this case, user did click this one, homeimprovement.com, right? This one. And then what URL did the browser refer to the user to? When they click here, URL will refer to this one, tyupenme.com. You can see inside here, right? This one, host. tyupenme.com means you can guess that this is the drive-by attack because it will refer to another source host. Then what kind of content is requested by the source host from tyupenme.com? Why could this be a problem? We can look into the DST server block of the transcript too. So when you see here, actually the requested content was a gzip file here. Gzip compress. It looks like our zip file in Windows. In Linux, they're using gzip. That could be a malware file that requested to download. So that request to download the gzip file. The file is compressed file and the content itself normally can be questioned. Oops, sorry. because it's quite difficult to see. It's obfuscated and difficult to see its content when they have a gzip compressed file or sometimes encrypted file. A network level IDS cannot analyze it in depth. So we just having the signature and predict that this is something that not a normal things. So this is why they use this kind of thing. Normally for gzip or encrypted file, HIDS will be more effective to be analyzed. Then you can close this browser. See here. From top of NLS alert dashboard, click HTTP entry under zig hunting. So we move to next. Zig hunting. Just HTTP. Want to look into the HTTP part log. Then verify. Look into, is it same part here? Start with 30. Try to adjust again the timestamp, start and end. 5600. 5600. Okay, this is what we have. Look here, HTTP. Okay, and you see here the scroll down to HTTP site section of the dashboard. This is HTTP site. What are some of the websites that are listed? You can see in homeimprovement.com, tyubandme.com, thebing.com, googleanalytics.com, blog, Cypher, and many more, right? If we download. So this is the site that involved with this packet transaction. We should know some of these websites from Transcript that we read earlier. Not all the sites that are shown are part of the exploit campaign. Research URL by searching for the internet. Do not connect them. So we try to find some of the things which will be part of the exploit campaign. Example here, homeimprovement.com. You can see Google. Make sure you put this one. Actually, this is the home improvement website, but it's not maintained properly if you go inside. So you see here, there are some blog that detect this homeimprovement.com is part of the untrusted website. You can see. Okay, you can find others. For example, other website like tuneme.com here. So most of the malware analysis engine, automated engine from anti-malware or antivirus, they already detect this one as part of the malicious website or malicious domain. We know already this one of the exploit campaign website. So you can go to another sample. But Google Analytics, when you find it is not the campaign lah. Probably Google Analytics is a normal website. Bing also normal website. Bing is a search engine from Microsoft. For example, one of it. Try to find. Okay, you can see server analysis of the server ransomware. This is part of the exploit kit exploit campaign. Okay, then what are the HTTP MIME type listed in the tag cloud? You can find here the answer. This is MIME type tag cloud, component of the HTTP text, HTML, text plain, content of JavaScript, and short wave flash. Actually, this is the one that it will exploit. Then part 2, we move to part 2, investigate the exploit with SQL. So now we can close this to minimize the resource usage. We go to the SQL. So we will use SQL to check the IDS alert and gather more information about the series related to this attack. The same credential, this, and CyberOps. I'm still here. Okay, what we need to do? So we need to enable all sensors. And talk about sensors in IDS, actually the interface, the interface name interface. So we need to enable all and start. Locate the group of alert from January 27. So go to date time. Okay, the first one here, January 27. Need to see what are the timestamp for the first and last of the alert that occur within about second or few. So this is the first one, 27, but the timestamp is more on 22, 44, 52, mean at 10 a.m. 54 minutes and 42 seconds. And then the series here until this one, right? Same series of attack. Until this one, 5.78, 22, 55, and 28. Less than a minute. The exploit occur in the least than a minute. You can see. Then investigate the alert in SQL. How to do this? Step A, click the show packet data. Show packet data here. And show rules. This is packet data, IP data, RTCP info, and data info. Then we have another part here more on the rules of each alert. This is not rules. Okay. This is rule for the one detected. Normally only the detected or map rules can be seen here. Alert. If not, they didn't alert anything. No, consider as normal packet. Select alert 5.2, the first alert, event message, this one. Evil director leading to EK July. Okay. According to the IDS signature rule, which malware family trigger this alert, you may need to scroll through the alert signature to find the entry. This one. You go here and find the family of the malware. You see here, malware family, sudo dark leech. This is the answer. You click the first alert and then you go to the packet or the rules. And you can see the family of the malware. Then maximize the single window and size event message. So we can drag others. Want to see the event message. According to the event message, what exploit kit or EK is involved? See here. The EK. Evil Redactor RIG. Okay, you can find the info here. Current event. Okay, this is the information you can get. Okay, itu then you see until here you see RIGEK, right? This is the type of exploit kit. Fine. Then beyond labeling the attack as a Trojan activity, what are other information provided regarding the type and name of the malware involved? You can find all the data inside here from each of the details. Trojan activity, you know. Then you can find what are the other information you can get. RG exploit. Until you find the name of the malware itself. I find this ransom server. This one. Ransom server check-in M3. This is the ransom server. This is the name of the ransomware. Attack as Trojan, but actually it's ransomware. The name is ransomware server. By your best estimate, looking at the alert so far, what is basic vector of this attack? How did the attack take place? For me, this is attack because of the user visit the malicious web page, because he or she did not aware about this, because the website looked legitimate but infected or injected by the threat actor. Sometimes you can use the SEO, search engine optimization, to make sure their website available in the top of the list, so that they can invite more victim on it. Step 3, view transcript of event. Go to this and then go to transcript. This is the transcript of the first one. What are the referrer, host, website that are involved in the first SRC or source event? What do you think the user did to generate this alert? From that, the user search for this home improvement, remodeling your kitchen term or phrase in the Bing search engine. Then the search engine give this result, homeimprovement.com link. And then the user visit that website. When they visit website, the attacker already embed their malicious code in that particular website. And then right click in the second, this one, third one. Okay, go back to source. To transcript for this, what we can see. Okay, what kind of request was involved? So this is the request. HTTP 1.1 get request. Where were any file requested? Yeah, they requested here. This is the file requested .js. .js means the JavaScript file. And then what is the URL for the referrer and host website? You can see the referrer here, improvement, and then the host, they use retrotip vision lubana.com.va is their landing page actually. How the content encode gzip, right? This one. So this is the information that you can gather from this transcript. Then we need to go to another event or alert 5.25. Open transcript again. Try to look into how many requests and response were involved in that alert. You need to go through how many. This first, second, and you got the blue one mean the request, red one is the response. Right. Three. So you have three alert, request and response. What the first request? You go to this first request, get resource, Vivaldi and so on. Later we can see what type of request here. And then who what was the referrer? We'll use same referrer here. Next, the host, they're using different host TYU for their landing page. And for the response encoded, yes, using gzip here. Then what was second request? We need to go to the second request here. More on post request. So we have one get, one post already. See the request. I just put the summary of it. Host server, same, using TYU BNB. And similarly, they will have gzip request. And then third request, you can see here, more on the get request as well. But they will have different requests, big requests. Who was the referrer? Same referrer here using this website. And then what was the content of type of this third response? This is the content type, application at shortwave flash. Okay, what were the first three characters of data in the response? The start data start last DST. Okay, this one last DST. So you can find the answer here, CWS, three characters. What is CWS? CWS actually for file signature to help identify the type of file that represent in different type of data. You can go to this info, Wikipedia, and find what related to CWS. And this one, put here, topic, file extension description. Okay. We'll use flash file.swf. Download swf file, which will be run using Adobe Flash application or Flash player. Then we can close the transcript. And right click in the same ID here, we will run the miner, network miner. Go to file. How many files? We have 3 files here, 2 HTML and 1 .swf file. Then next we will use Wireshark in part 3. So here just remain scroll here. Still in Square, we go to alert 5.2, right click and click Wireshark. Wireshark already embed inside the skill. Okay, now we need to filter first what type of event and what type of traffic you want. First, try to view the time. Go to view, time display format, date time, and the day. Okay, then another one, second. Second, we move to okay, second already. Okay, done. We'll see same thing here. Then step 2, using http.tref request filter, so that we have only 3. Then output here we found. Select the first packet in the packet details and expand the HTTP application layer data. This one. So what we can see. What website direct the user to the www home improvement. This is www home improvement. Will be using bing.com, right? It was using bing.com to search the info and then click the home improvement, and bing.com giving the result. Step 3, view HTTP object, export object file, export the object HTTP. So we have these 3. Go to this one, save home folder. This is my home folder. I will save it here. Okay, yes. This is okay. No problem already. Save it. Then close Wireshark. Then go to this 5.2.4. Choose Wireshark as well. One more time, you filter HTTP dot request. So we have one alert only here for the HTTP. Then what is the HTTP request for? Click. Oh, hang. Okay, what we have here. Go back to my. What is the HTTP request for? You can see HTTP request the DLE.js get right. Request URI engine class DLE.js JavaScript file. What is the host server? The host server use referrer. This one host retrotip vision bana.com. Okay, same thing here. This is my answer. In Wireshark, export the file, export the object, and save this file. I have saved already, no problem. Use. Then close. Then we go to another alert. So using Wireshark, apply the HTTP request again, and we have three alert here. You can see in info, get, post, and get. To get, one post request, as we looked earlier from the previous info. With the first packet selected, the packet detail area are expand. So go. This one. So you have a host already here. Apply the column. Apply already the column, then I got this host. Okay. Or S column. So I can have this. Oh no. 2. Then I have here already. No need to add on. make room for the host column, right click and header uncheck it. So the header already disabled. Remove the length column, so no need to display it again here. So the length I already disabled. Then create a hash order and export the malware file. How to do that? Good, it's the same thing. You need to export the object HTTP. Actually, I already exported all, no problem. Now that you have saved 3 files, so to see if one of the file match non-hash value malware virustotal.com, issue ls command to look at the file saved in your home directory. This can be done in using your terminal. Okay. Yes. Now, this is what you have inside your home directory. And the flash file has word cmonkey, so you can find one of the file that contain cmonkey word. Yes. Okay. Grab cmonkey. So we'll get this file that we saved already. One of the malicious file. Generate SHA-1 hash for the cmonkey flash file. So go to SHA-1 sum, then you put the name first, then tab. It will give you the full name and enter what you get. So when you enter, the system will generate. This is the hash value, SHA-1 hash value. Okay, for me, I just copy first the value using some of the file editor. Okay, I like using gedit. So this is the value, not here, not copy yet. The value here, copy. This is the hash value for this file. So you can also generate hash value using network miner. This is the second option. How to do that? We need to open the SQL. Example, network miner. This is the network miner. So go to file. This is the file. You can calculate this one. So this is the value as well. Either you want to check based on ND5 algorithm, SHA-1 or SHA-256, you can find. But for this one, we're using SHA. Maybe you can copy to compare. Is it similar or not with the one that we generated? Yes, same thing. The same value will produce the same output of hash value. Okay, one way hash value. And then we go to the virustotal.com. Use this. And search for the hash value. That hash value. Then you see here, this is the latest info from the virus total. Investigate the detection later tabs. Okay, this one you can look into these two. If you run the MD5, then you can get the same value here as well. You can compare one way hash function. So what I found here, actually there are 35 out of 60 antiviruses or anti-malware engine detect this file as the malicious file. And we can also verify that the SWS file is part of the RAG-EK exploit kit. How we find it? Actually everything here. Detection. So from GetQuick engine, from nlab 33 engine, right, adware. Most of engine already detect SWRIG exploit. So see here, Bitdefender also found that this exploited from the CVE, common vulnerability exposure. This so close the Wireshark. Browser and Wireshark. Yes, close first. Will consume our resource. Then go to another 5.37, the last part here. Go to Wireshark. One more time using HTTP request. Oops. So we have three alert: SIM, get, post, and get. As we have similarity to this website, you can see. Same thing. So all will go to tyu.nme.com. Are the files similar? Yes, they have three files as well. Here, the info. Let's see. How to find the file? See the file, right? File name. Two HTML file and one flash, same like previously, but the name are different. You can see the name are different. Then we create a SHA hash of the SWF previously. You can do the same thing, and you save already. Either you want to use this one, or you want to use your network miner. Up to you. This one, right? Use here. Network miner is there. you want to check the SF or the SHA-1 for flash file. This is the flash file SHA-1 for this alert. So I can compare back to the previous one. Start with 97 and with 290. Is it correct? This is the previous one, right? And check. Actually same value, because the SHA-1 is more on the content, not for the file name, content of the file. I digest. Here the two hash match even though the file name are different. The SQL last for alert in this series are related and they are also sensitive post infection. So we need to go back to the SQL and look into the last for alert. Where is it? You can start this one. 1, 2, 3, 4. This last 4. We start with this 5.75. Why do they seem to be post-infection? You see here, you can try to look the packet here. Actually, they will go to ransomware server. You can go here, or you can find from the transcript or Wireshark. Oops, cannot this one, TCP, not TCP. You can go to Wireshark. Okay, see here, destination UDP, source destination 992, right? So all for alert concern communication with the malware server, Trojan horse here, ransomware you can find. What is interesting about the first alert? The first alert of the last 4 here using UDP. You can find here alert UDP. Ransom server check-in. This is the second last or the third last, also using UDP. Same thing here, UDP as well. Only the last one using TCP. So what type of communication is taking place in the second and third alert series? This one. Second and third. They are DNS requests that initiate from the local host. Oops. Okay. Find here. Second and third, right? You can go to this one. DNS. Okay, DNS query. Initiate from localhost. However, it's unlikely that they are result from normal activity. Normally, this will be sent by the malware. Because when you see the top domain does not look like a valid domain here. This one. See? Normally domain didn't use this kind of name. very difficult to remember, right? No, what we call, no meaning. Normally, domain name system will use the easier name that we can remember. This is how we look into the malicious link and malicious website. Then what is the result? It is malicious domain that still trigger alert from 90 from 6 out of 83 malware engine. How to do that? You can find the name here using the top domain part. Okay, go to virus total and then you find the name, this URL, this value. Okay, you go back to the virus total and find based on the URL. URL and find here. So you see 6 out of the 83 engine still detect this URL as the malicious URL. For Fortinet, Bitdefender, Sophos, Trustwave, this is the big or established anti-malware as well. And examine the last series in Wireshark. Because this is TCP, you can visualize it in Wireshark as well as the transcript. But this one more on the Wireshark, the last one. So what type of object? Find export end object. Yes, one object here from this host name and save. I already save it. Done. So what are the file name, if any? This is the file name. Go back. File. Start with EE. This is the file name. HTML file. Done for step 3 or part 3. Next, the last part we need to look into how to examine the exploit artifact. In Security Onion, open the remodeling kitchen cabinet.html file using any part or any application. Close this. Okay, try to find our home. So need to open the remodeling. This one I prefer to using gedit only. It's look like our notepad. So you can find two places in the web page that are part of the drive-by attack that started the exploit. First hint, the first is the head area and the second in the body area. I found here the first head actually more on the Java script file. Okay, where is it? This one. Head first. This is the title, head. So script type here, JavaScript. The sources are from their landing page. So they will download or execute the Java first. Then the second one, iframe inside. Load the T inside the body. This one inside the header. Okay. From here you see iframe. They embed the iframe function here, but actually they will redirect to tayubnme.com request to the sources. Okay, this is the thing. Open the JavaScript file. So now we look into JavaScript file. What happened to JavaScript? This one, dle.js, edit. What we have, the iframe. JavaScript document write function will write content to the web page, creating a iframe that take the user to the URL at tayubnme.com here. Okay, and then what happened? How does the code in the JavaScript file attempt to avoid detection? So you see here they split the iframe into different name here. IFR plus AME here. So that is not detected as iframe, normal iframe. The text editor open the text HTML file that was saved on your home folder with Vivaldi. So next, Vivaldi here. Okay, this one. Open back what you have from the source code. What kind of file? This is normal HTML file. Looks like normal HTML file. Alright, HTML. We have all the head, body, but we got also iframe here. What some interesting about this iframe that does is called anything. When see here, visibility are hidden. The iframe itself are hidden from the user. It's called stat function here. Or the function start function here. Okay, inside the iframe. Then what does the start function do? It will write to the browser window. It will create HTML form and submit the variable normal URI through post. The normal URI variable equal to URI at tayubnme.com. This one. They create a variable, but actually the same thing, they will redirect the value of the variable actually to redirect the traffic into this tayubnme.com. There's another way of redirecting the access. What do you think the purpose of get browser function is? This one. Normally, to determine the type of browser that the web page is displayed in, so that they know what type of browser, what type of search engine normally used in the browser use, and then normally from that browser also can define or identify the CVE or any exploit things that they can do. And lastly here, reflection. Exploit kits are fairly complex. Exploit they use a variety of methods and resources to carry out an attack. This is only part of the thing that we can find. There are a lot more. Interestingly, EK may be used to deliver diverse malware payload. This is because EK developer may offer exploit kit as a service. Nowadays, exploit kit as a service to other threat actors. Therefore, a rigged EK has been associated with a number of different malware payload. The following question may require you to investigate data further using the tools that introduce the lab. So you can find from the packet, the bing.com actually what, and then the homeimprovement.com, the IP address here. I will refine it using all the resources inside. What is it actually? What happened? Malicious iframe redirect to malicious site when they already inject accept the malicious code inside the main page. And then they have another URL, retrotrip.com. This is the IP address I found from the packet. And then execute malicious JavaScript. TYU and me actually deliver malicious .flash file, exploit landing page. You see here, they will go to this one first, then this TYU ban me as their exploit landing page. When user visit this website, they will download the Adobe malicious file, Adobe Flash. We have one more address here. You see in where is our school? Okay, this one. What actually destination IP of this 90.2.1. No URL and no DNS URL, but they got IP. So I found that this is the Kerber ransomware check-in server, which normally will use to for the communication between the victims and the ransomware server. Then the one that we identify as malicious URL, the IP address, is the server ransomware page itself. Okay, this is what I found here. So it is useful to tell the story, so understand how it works. So from what we did, I found that the user start searching with the Bing search engine for information on the home improvement. Then the user click a link to www.homeimprovement.com once the Bing search engine giving the result. And then the website actually already compromised by the threat actor. When the user click the link, the JavaScript executed and download a malicious flash file. RIG EG have been using flash exploit based on the CVE list available. The flash file execute and download malware in the victim machine. After the malware install, it will be communicate with command and control server, which actually this Kerber ransomware check-in server. In this case, this one. That's all for this lab. Thank you.